we will prove a lemma, which is the linearity of this thing. So what we are going to do is that we are going to prove that this map, which maps f to this integral. So think about it as a map from a function to a number. Such maps are called functionals. So if you wonder about the term functional, so functional is a map. Functional is a map which maps a function to a number. And these are called functionals. And the lemma is claiming now that this is a linear functional. This integration is a linear functional. And more precisely, the claim is that the integral of c times f plus d times g is equal to the integral of c times the integral of f plus d times the integral of g. For all, now we are still in the positive realm, so we require c and d to be positive, and then we require f and g to be non-negative and measurable and simple. That means finite range. That's our claim. And let's do the proof. Let's denote this sum as h. Okay, and let's write the range of f as f has a finite range, so we can write it down by some numbers a1 up to am. And then let's write the range of g using numbers, let's call them b1 up to bn. And let's write down ai to be the pre-image of the value ai, and let's write down bj to be the pre-image by the function g of a singleton set with number bj. Okay. So then, what do we know about the range of age? Is it finite, or could the range of age be infinite? Give me green light if you think that range of age is finite. Give me red light if you think that it could be infinite. I only see green lights. That is, these are correct answers. F takes on finitely many values, G takes on finitely many values. So if you look at what are the possible values of this sum, there could be only finitely many such values. And actually, we could write them down in principle as we look at all the linear combinations or all of these type of values, where I is ranging from 1 to m and j is ranging from 1 to n. Yeah. This is the range. That's one way to write it down. It's not a very convenient thing, but we can do it in this way. Then what else can we say? We can say that the value of age at point S is equal. When is it equal to c times ai plus d times bj? This is true when S belongs to a set Cij that we will write down as intersection of ai and bj. So let's write down, this is important, so let's use different color. Let's use green here. So Cij is set the intersection here, and if you think that we take a point in Cij, so then this point belongs to ai and it belongs to bj, so that's why hs must take this value for this set. Then what is important about this Cij is that these are disjoint sets for different ij pairs, because AIs are disjoint They are pre-images of distinct values, so AIs are disjoint. BJs are disjoint also mutually. So this is why also CIJs are disjoint with like indexed by IJ in this product set 1M, 1 up to N. Okay, so that doesn't fit, but I think you understand that I'm thinking of I and J indexed by all possible choices. So these are disjoint sets, and that's what we are going to use, because we remember that measures are additive on disjoint sets. And then we are ready to do a calculation for this integral of age. So let's look at this integral of age using these notions. Let's calculate what is the integral of age and we use the definition that we are summing over the range of age, possible values x, and then the measure of the pre-image of that particular value. And then we look, okay, the pre-image of certain point, so any point x is one of these that we look at here. So, and one way to write down this pre-image, that's the most complicated part of this analysis. So we write actually this set here. As the union of ij pairs such that C times AI plus D times Bj is equal to X. We look at all the combinations that can produce us the value X. And we write here Cij. This is the complicated thing that is key to the proof. If you look at this for a little while, think about X belonging to one of these. So then that's matching with this. If we use this property and we note that these are disjoint, these are still disjoint here. So then we can write this measure as the sum. So we now change it to the sum of I and J pairs such that this property is true. C times AI plus D times Bj is equal to X. And then we write here the measure of Cij, but now we note that it's the measure of AI intersection Bj. And this is what we can do. And now with this understanding, we reorganize this sum. So we reorganize as the sum of X in the range, and then the sum of these ij pairs. And then we have the value of X here, and then we have the value of, let me write it once more properly. We have X there, and then we have this mu of AI time intersection Bj. Now we have just reorganized the sum. Now we are looking at, okay, such pair I and J for which this is true, X is equal to this. So now what we can do, what we have here is value X. But we also know that this sum is equal to X. So we can plug in, instead of X, we can write here this sum. And that's what we are going to do. So I will clean it up and I will write here the sum C times AI plus D times Bj. Now it goes to the sum, and that's where we are. Next, we note that, okay, we are summing over all X in the range of age, And then we look at all the pairs for which this is true for some age. So actually, these two sums, kind of for every x, there is we are actually going through of all possible pairs I and j. So what I'm saying is that we can translate this to the sum where I goes from 1 to m and j goes from 1 to n. We are looking all the pairs, and then we just write this what we had there, c times ai plus d times bj, and then the measure of ai bj this way. And that might take a little bit of contemplation, but let's not use the time here. You can repeat it later if you like. So if you trust me with this, so then we are here, and we have kind of translated this simple integral here, or this square integral concept, to a kind of simple type of sum. What next? Let's reorganize this sum once more. Let's reorganize it so that we have these are finite sums, so we can reorganize things so that we put c to the front, then we put I from 1 to m there, ai there, then I'm putting sum j from 1 to n mu ai in the section bj, and this is n, yes. Then I take the other sum here, and I put d to the front, j from 1 to n, then bj to the front, and then to the inside sum, let's put I from 1 to m, and then the measure of ai in the section bj here. Okay, that's just reorganizing finite sums. What can we say about this thing here? If you look at this and you look at these sets, so let's look at these sets carefully. Think about I as fixed and then j as changing. So we are looking at the collection of sets ai intersection b1. Then the next set is ai intersection b2. And then finally we have ai intersection bn. Yeah. Then we recall that b1, b2, sorry, this was supposed to be b2. b1, b2, bn, these are disjoint, these b sets. When we intersect these disjoint sets by AIs, these remain disjoint. So these are disjoint. What is their union? Because now we are looking at the measure, so we can actually plug this sum into a union inside the measure. So what's the union of these, all of these? The union of all of these is equal to AI intersection, the union of BJ. J from 1 to n. Yep. What's the union of BJs from 1 to n? Does somebody know? Let's recall what these BJs were. BJs were the possible values of the pre-images of G, and we take all the possible values of G. So the union is actually the full set. So if we go back, we know that this union is actually the full set S. And intersection AI with the full set is just AI. Yep. So we take the sum inside, this becomes a union, and the union of these disjoint sets is just set AI. Yeah. So that's why let's clean this up and know that what we are actually looking at is that we take the what we have here is the C times I from 1 to M AI times just the measure of AI here. The same thing works symmetrically here. And now think about these are disjoint with respect to I. Now we are indexing with I here, and they are disjoint, and the union of these becomes Bj. So we get here the measure of Bj here. And then if we recall, what was this? We were looking at the possible values of f. So this is just the integral of f. And this is just the integral of g. And what we did, we started with the integral of h, which was the sum. H was the sum of these, and we proved that the sum of the integral of the sum is the sum of the integrals. So what we have here, this is the end of the proof.